This video describes a new procedure added to Statgraphics Centurion version 20 for analyzing Type 1 gauge studies. Type 1 gauge studies are used in measurement systems analysis to estimate the repeatability and bias of a measurement system. They're often used before a more complicated Gage R&R study is conducted to be sure that the repeatability of the measurement process is small enough that such a study is likely to be successful. The data for a Type 1 gauge study consist of repeated measurements, usually at least 50, by the same operator on the same part using the same equipment. As an example, we will consider 50 measurements made of the diameter of a golden sample. That is, an item for which the actual diameter is known. In Statgraphics version 20, you'll find the Type 1 gauge study on the main menu under SPC, Gauge Studies, Variables R&R. The first dialog box displayed will request the name of the column containing the measurements. The next dialog box specifies analysis options. This includes a reference value, a tolerance, an optional resolution, the sigma multiple to be used for the tolerance analysis, and the percent of the tolerance to be used when computing capability indices. The reference value is the true value of the characteristic being measured. In this case, the actual diameter of the part. The tolerance is the distance between the specification limits. That is, the upper spec limit minus the lower spec limit. The resolution is the resolution of the measurement equipment being used. This is related to the number of significant digits in the measurements. The sigma multiple for tolerance analysis is the multiple of sigma used to compare the spread of the measurement error to the distance between the specifications. By default, we usually use 6 sigma. And finally, the percent of tolerance for capability analysis is a coefficient P, which represents the percentage of the tolerance used when computing the capability indices. By default, P is set to 20%. As part of the output of the Type 1 gauge studies procedure, a run chart will be displayed. Here you see the 50 measurements plotted with a center line at the reference value of 0.1. You'll also notice a green line very close to the reference value. That's the sample mean, the mean of the 50 observations. Since we specified a value for P of 20%, you'll also see upper and lower limits at plus and minus 10% of the tolerance. The primary numerical output of the procedure is shown on the analysis summary table. It has a number of different sections. At the top, you'll see the summary statistics. That is the sample size, the sample mean, and the sample standard deviation. You'll then see 4 sections: a tolerance analysis section, a bias analysis, a capability analysis, and a variance analysis. The tolerance analysis compares the tolerance with K times sigma. The tolerance should be much larger than K sigma, since sigma here only measures the variation of one operator on one part. sigma will be considerably larger when we do a full Gage R&R study. The resolution percentage, which is the resolution divided by the tolerance, should be no more than 5%. The bias analysis calculates bias, which is defined as the sample mean minus the reference value. The t-statistic, shown here, tests the hypothesis that the bias equals 0. The p-value, if less than 0.05, would indicate statistically significant bias in the measurement process. In this case, there is no significant bias. The capability analysis section shows two calculated capability indices, CG and CGK. By default, CG compares 20% of the tolerance to K sigma. Standard guidelines suggest that CG should be greater than or equal to 1.33. CGK compares 20% of the tolerance to K sigma with an allowance for bias. CGK should also be greater than or equal to 1.33. In this case, CG and CGK are both very good. Finally, the variance analysis calculates the percentage of the tolerance covered by the measurement error, both with and without allowance for the bias. Since we're using p equal 20%, our goal here is for these statistics to be no more than 15%. In this case, they're very good. Since all of the guidelines have been met, it would make sense to move on to a full Gage R&R study using multiple operators and multiple parts.